My dear students, welcome back to our channel. In this video, I will be explaining the Bcom third semester subject RDBMS as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 1 first important short question is Database and types of databases. A database is a collection of organized data that can be easily stored, accessed, and managed. Think of it as a digital storage room where all important information is kept safely. Types of databases. 1. Hierarchical database. Data is stored in a tree-like structure. Each record has a parent and child. Example, organization structure with manager team employees. 2. Network database. Data is stored in graph-like structures with multiple relationships. Example, airline reservation system connecting flights, passengers, and bookings. 3. Relational database. Data is stored in tables, rows and columns with relationships using keys. Example, student table with student_ID, name, class, and marks. 4. Object-oriented database. Data is stored as objects, similar to programming languages. Example, multimedia applications storing images, audio, and video objects. Remember, databases are like different storage styles for different needs, tables, trees, graphs, or objects. Next important short question is 2. Data dictionary. A data dictionary is a special storage that contains information about the database itself. It is like a database about the database, helping the RDBMS and users understand how data is organized. Functions of data dictionary. 1. Stores metadata, contains details about tables, columns, data types, keys, and constraints. Example, in a student table, it stores that student_ID is an integer, primary key, and cannot be null. 2. Helps in database design, shows relationships between tables and attributes. 3. Ensures data consistency, keeps all users informed about data formats, preventing errors. 4. Supports security, helps track which user can access or modify which data. Example, in a college database, the data dictionary will record that the marks column in the exam table is numeric, max 100, and linked to student_ID. Remember, data dictionary is equal to database's instruction manual. Next important short question is 3. Relational keys. In a relational database, a key is a field or a set of fields that helps identify a record uniquely in a table. Keys are very important because they keep the data organized and consistent. Types of relational keys. 1. Primary key. PK uniquely identifies each row in a table. Example, in a student table, student_ID can be the primary key. 2. Candidate key, any column or combination of columns that can be chosen as a primary key. Example, email_ID can also uniquely identify a student. 3. Super key, any set of attributes that can uniquely identify a record. Example, student_ID, name, is a super key. 4. Foreign key, FK links one table to another, ensuring referential integrity. Example, class_ID in student table refers to class table. Remember, keys are like ID cards for records. They make sure every record is unique and connected correctly. Next important short question is 4. ACID properties. In RDBMS, ACID ensures that database transactions are reliable and safe. ACID stands for atomicity, consistency, isolation, durability. 1. Atomicity. A transaction is all or nothing. Either it completes fully or it does not happen at all. Example, transferring 100 rupees from A to B, either both debit and credit happen or none. 2. Consistency. After a transaction, the database must remain valid and follow all rules. Example, a student's total marks cannot exceed 100. 3. Isolation. Transactions are independent. One transaction does not affect another running at the same time. Example, two users updating marks in different subjects simultaneously won't mix data. 4. Durability. Once a transaction is completed, the changes are permanent even if the system crashes. Example, once a student's result is updated, it is saved permanently. Remember, ACID is equal to safe, reliable, consistent transactions. Next important short question is 5. Integrity constraint. In a relational database, an integrity constraint is a rule that ensures the data is accurate, correct, and consistent. These rules prevent wrong or invalid data from entering the database. Types of integrity constraints. 1. Domain constraint. Values of a column must be from a specific set or type. Example, marks in a subject must be between 0 and 100. 2. Key constraint ensures each row is uniquely identified. Example, student_ID in a student table must be unique. 3. Entity integrity. A primary key cannot be null, so every record can be identified. Example, every student must have a student_ID. 4. Referential integrity. A foreign key value must match a primary key in another table or be null. Example, class_ID in the student table must exist in the class table. Remember, integrity constraints are like rules for a database. They keep data organized, safe, and reliable. Next, Unit 1. Long questions. First important long question is 1. Explain the advantages of RDBMS over file-based system. Advantages of RDBMS over file-based system. A file-based system stores data in separate files for each application, while a database management system, RDBMS, stores all data in a centralized database. RDBMS has many advantages over traditional file-based systems. 1. Data redundancy control. In file systems, the same data may be stored in multiple files, causing duplication. RDBMS stores data centrally, reducing redundancy. Example, in a college, student details are stored in one table instead of repeating in marks, attendance, and fees files. 2. Data consistency. Since data is centralized, RDBMS ensures consistent information across all applications. Example, if a student changes their address, it is updated everywhere automatically. 3. Data integrity. RDBMS enforces rules called integrity constraints to ensure data is valid and accurate. Example, marks cannot exceed 100 in any subject. 4. Data security. RDBMS allows user access control, so only authorized users can read or modify data. Example, teachers can enter marks, but students cannot change them. 5. Efficient data access. RDBMS provides query languages like SQL, making it faster to search and retrieve data compared to manually searching files. Example, finding students with more than 90 marks in maths takes seconds with SQL. 6. Data independence. Applications are not tightly bound to data storage, so changes in data structure do not require rewriting programs. 7. Backup and recovery. RDBMS automatically supports backup and recovery, protecting data from accidental loss. 8. Concurrent access. Multiple users can access and update data simultaneously without conflicts. Example summary. In a college, RDBMS allows students, teachers, and admin to share and update student data efficiently, securely, and accurately, unlike file-based systems where separate files create errors, duplication, and delays. Remember, RDBMS is equal to centralized, consistent, secure, and efficient, the modern way to manage data. Next important long question is: to explain logical RDBMS architecture. Logical RDBMS architecture. The logical RDBMS architecture is a way of organizing a database so that users can access and manage data without worrying about how it is physically stored. It separates the database structure into three levels: external, conceptual, and internal. This is also called the three-level architecture. 1. External level, view level. This is the user's view of the database. Each user may see the data differently depending on their needs. Example, a teacher sees student marks and attendance, while a student sees only their own marks and timetable. 2. Conceptual level, logical level. Represents the entire database logically, showing all data and relationships without worrying about how it is stored. Example, the database knows that each student is linked to a class, their marks, and attendance, but users do not see this internal mapping. 3. Internal level, physical level. Deals with how data is actually stored in the system, on disk, indexes, file structures. Users don't see this level. Example, student records are stored in rows and columns on the server's storage. Advantages of logical architecture. Data independence. Changes at the internal or physical level do not affect user views. Security and privacy. Users can only access their external views. Simplified management. DBAs can manage data centrally without affecting applications. Example, in a college database, the teacher views marks, external level, the RDBMS knows relationships between student, marks, and classes, conceptual level, and the system stores all records in tables on disk, internal level. Remember, logical RDBMS architecture is equal to user views separate from logical database, which is separate from physical storage. This ensures flexibility, security, and easy maintenance. Next important long question is: 3. Explain three-level architecture of RDBMS. The three-level architecture of a RDBMS is a design that separates the database system into three layers, making data management easier, secure, and flexible. This architecture ensures data independence and helps users work without worrying about how data is physically stored. The three levels are: 1. External level, view level. This is the user's perspective of the database. Each user sees only the data relevant to them. Example, in a college, a student sees only their marks and timetable, while a teacher sees marks of all students. 2. Conceptual level, logical level. This level represents the complete logical structure of the database, showing all entities, attributes, and relationships. It hides the physical details of storage. Example, the RDBMS knows that each student is linked to a class, their marks, and attendance, but users don't see these internal structures. 3. Internal level, physical level. This level defines how data is actually stored in memory or disk. It includes storage structures, indexes, and access paths. Example, student records are stored in tables with rows and columns on a server. The internal level manages this efficiently. Advantages of three-level architecture. Data independence. Changes in physical storage or logical structure do not affect user views. Security, users see only the data allowed for them. Simplified management, DBAs can manage the database centrally without affecting applications. Efficiency, optimizes storage and access paths for faster operations. Real-life example. In a college database, student view, external sees only their own results. Database knowledge, conceptual system knows relationships between students, classes, and exams. Storage, internal records stored in tables with indexes for fast retrieval. Remember, three-level architecture is equal to external, user view, conceptual, logical DB, internal, physical storage. It ensures flexible, secure, and efficient data management. Next important long question is 4. Explain the role and functions of DBA. Role and functions of DBA, Database Administrator. A DBA, Database Administrator, is a person responsible for managing, organizing, and securing a database. Think of a DBA as the guardian and manager of the organization's data. The DB ensures that the database runs efficiently, safely, and reliably. Roles of a DBA. 1. Data Manager, maintains the database structure, tables, and relationships. 2. Security Manager, controls user access, making sure only authorized users can read or modify data. 3. Backup and Recovery Expert, regularly backs up data and restores it if any failure occurs. 4. Performance Monitor, ensures that queries run efficiently and optimizes database performance. 5. Problem Solver, troubleshoots errors, fixes issues, and maintains smooth operation. Functions of a DBA. 1. Database Design, helps in designing tables, keys, and relationships based on requirements. 2. Data Integrity and Consistency, enforces rules to keep data accurate and consistent. 3. Access Control, defines who can see or update data. 4. Monitoring and Tuning, observes database performance and makes improvements. 5. Maintenance Tasks, upgrades software, manages storage, and ensures smooth operations. Example. In a college, the DBA manages the student database. They ensure that teachers can enter marks, but students cannot change them. Student records are backed up daily. Queries like list all students scoring above 90 run quickly. Only authorized staff can view sensitive data like fees. Remember, the DBA is like a database superhero responsible for security, efficiency, backup, and smooth functioning. Without a DBA, databases may become slow, insecure, or inconsistent, causing major problems for organizations. Next important long question is 5. Explain Entity Relationship, ER, model with examples. Entity Relationship, ER, model. The Entity Relationship, ER, model is a way to visually represent the database structure. It shows entities, their attributes, and the relationships between them. ER model is widely used in designing databases because it is simple, clear, and easy to understand. Key components. 1. Entity, a real-world object or concept about which data is stored. Example, student, teacher, class. 2. Attribute, a property or characteristic of an entity. Example, student entity may have attributes like student_ID, name, age. 3. Relationship, shows how two or more entities are connected. Example, enrolled relationship between student and class. Types of relationships. One-to-one, one-one, each entity in one set is related to one entity in another set. Example, each principal has only one office. One-to-many, one, and one entity relates to multiple entities in another set. Example, one teacher teaches many students. Many-to-many, M and many entities relate to many entities. Example, students attend many courses, and each course has many students. Advantages of R model. Easy to understand and communicate. Helps in database design before actual implementation. Ensures that all entities and relationships are properly identified. Example. In a college database. Entities student, class, teacher. Attributes student_id, name, class_id. Relationships enrolled between student and class, teaches between teacher and class. Remember, R model is equal to entities plus attributes plus relationships. It is like a blueprint of a database, showing how data is connected. After designing an R diagram, it can be converted into tables in a relational database.